Hey there! Welcome back to the Nauctis on YouTube. For years, trains have been a mode of transportation for people worldwide. Due to high demand, several countries have started creating bullet trains and high-speed trains. With the presence of these trains, passengers can experience quick and punctual rail journeys. One of the countries with the best bullet trains is Japan. Japan has developed a bullet train called Shinkansen, produced on the outskirts of Sendai City in Miyagi Prefecture, Japan. The Shinkansen production facility spans an area equivalent to 70 soccer fields and includes maintenance and inspection facilities for bullet trains. These facilities handle 6 different types of carriages, totaling 1,200 units. Shinkansen has several series, one of them being the E5 series, capable of reaching a top speed of 320 km/h. To ensure the train's performance remains excellent, there are 4 levels of inspection and maintenance. Firstly, a visual inspection is carried out every 2 days, checking various components such as wheels, brakes, and pantographs. The pantograph on Shinkansen trains supplies 25,000 volts of electricity from overhead cables to power the train. The pantograph features an overhead line made of 15mm copper wire. If the pantograph does not maintain the correct spring pressure to keep it in contact with the wire, the train cannot operate properly. Before inspecting the pantograph, a worker first switches off the power. Then they climb onto the train's roof to check the pantograph and ensure it is in good condition. If there are issues with the pantograph, such as wear that could prevent the train from carrying passengers to its destination, they must identify and repair it. Pantograph inspections are typically conducted during the late night hours when the train is not in operation. In the second stage, routine inspections are carried out every month to check and replace parts that experience friction, such as axles being tested for damage and cracks. This inspection is unique and straightforward, as it does not require dismantling the train wheels. Specifically, during the inspection, engineers use a specialized tool, an ultrasonic scanner, which is inserted into the axle's hole on the train to detect any damage or cracks. The third stage of train inspection involves examining the bogie, which occurs every 18 months. The bogie is a critical part of the train and requires extra care. To inspect it, the train is dismantled and the chassis is lifted from the bogie. After disassembling it, the first part of the bogie to be repaired is the train's wheels. As the train runs, the wheels experience wear and tear. Therefore, workers restore the wheels to the correct profile. During this repair stage, the train wheels are adjusted from their original diameter of 850mm to 845mm. The dimensions of each wheel must be precisely matched. Each wheel is measured accurately to within 0.2mm. Even the slightest deviation in diameter among the wheels on each side can disrupt the quality of the journey and increase the risk of accidents. It is this meticulous measurement system that makes the Shinkansen considered safe for operation. In the fourth stage, a general inspection is conducted at intervals of 1.2 million kilometers every 3 years. Not only are the bogies and train wheels inspected, but also the instrument and machinery parts as well as passenger seats are dismantled and checked. The general inspection includes repainting the entire train body, and after this, the train can resume its operation. In addition to these 4 stages, there is another special train called the Dr. Yellow, which is used to inspect the Shinkansen rail lines. Dr. Yellow is a special-purpose train owned by the Japan Railway Company, used to check the overhead lines and other infrastructure on the rail lines it travels. When measuring any distortion in the rails, Dr. Yellow can travel at the same speed as a regular train. Dr. Yellow is used to determine if the line meets specified parameters. For example, if the overhead line touches the pantograph, it can cause sparks. If left unchecked, this could result in damage or disruption of the overhead line or the pantograph. To prevent such accidents, the diameter of the overhead line is measured at 5 cm intervals. The measurement must be accurate to within 1 in 100 millimeters. Once these measurements are approved, workers begin repairing the track overnight. Every night, 3,000 workers are deployed to maintain the Tokaido Shinkansen rail line. In addition to the rail lines, workers also replace worn-out overhead lines. As we know, Japan is prone to earthquakes. To address this, the Shinkansen has long used advanced seismic safety features. Since the Shinkansen is powered by electricity, the railway company also has special electrical substations that directly supply power to the Shinkansen. These electrical substations are equipped with seismometers that can detect vibrations above a certain threshold on the rail line. If the feature detects vibrations, it automatically cuts off the power supply and stops the train on the track. The Japan Railway Company has 97 seismometers along the Tohoku Shinkansen rail line and the nearby coastline. Large earthquakes generate primary waves with weaker vibrations. A few seconds later, they are followed by secondary waves with stronger shakes. The Shinkansen seismometers can detect these seismic waves and automatically cut off the power to the running train. Within 3 seconds of cutting off the power supply, the train will automatically initiate an emergency stop. In addition to Japan's advanced Shinkansen trains, Russia also has high-speed trains known as Sapsan. Sapsan is named after the peregrine falcon, which can fly at speeds of up to 390 kilometers per hour. This inspired Russia to build high-speed trains that offer both speed and comfort to passengers. Sapsan trains initially started regular services on the route from St. Petersburg to Moscow, reaching a maximum speed of 250 kilometers per hour. Sapsan trains can accommodate up to 604 passengers in one journey. These trains are equipped with advanced technology tailored to Russia's extreme climate conditions, which can reach temperatures as low as -40 Fahrenheit. Sapsan trains also feature double heading capability, allowing them to pull up to 20 carriages, totaling 500 meters in length. With this capacity, Sapsan trains set records as the longest and fastest high-speed trains in the world. When a Sapsan train has traveled a distance of 3.7 million kilometers, it undergoes an overhaul and maintenance process known as the mega pit stop. One of the maintenance centers, or mega pit stops for Sapsan trains, is located in St. Petersburg, Russia. The R3 revision maintenance process involves a thorough overhaul of the train, taking up to 34 days to complete. The R3 revision process begins by observing how the wheels rotate and how the bogies function. Engineers can detect any damage to the bogies and wheels by listening to the sounds they produce. In addition to listening to the wheel and bogie sounds, they also inspect the train's exterior to ensure there is no damage. One of the areas they check is the train windows, which can sometimes develop cracks. After the train is brought to a halt, technicians start their work by disconnecting the electrical current from the overhead lines of the train. This task is hazardous as they deal with electricity at a strength of up to 3,000 volts. Project managers also inspect the train's interior, including checking the passenger seats in each carriage. Next, technicians begin cleaning the train's water tanks using a citric acid solution and disinfectant. The train's toilets are also disassembled and cleaned by the technicians. They also inspect the train's kitchen and ensure that any damaged or faulty equipment is replaced or repaired. The most complex part of the process is lifting the train and detaching and replacing the train's chassis. Not only that, but workers also replace the pantograph and refurbish the train's electronic devices. All 604 passenger seats are dismantled and replaced with new ones. Sapsan trains are quite long, and to facilitate the maintenance process, they must be separated into two parts. Before splitting the train, the workers disconnect the train's electrical cables. Once this is done, the technicians can separate the train into two sections. Once separated, the other part of the train is moved using a diesel locomotive to a paint shop. Before painting, the technicians will address any dents in the train. The painting process can consume as much as 140 kilograms of paint. Meanwhile, the other part of the Sapsan train has its bogies removed and ensured not to interfere with other systems underneath the train, such as compressors and power converters. Once the underside of the train is dismantled, the technicians proceed to lift the upper part of the train using a specialized jack. The jack must be precisely positioned, as any error could lead to the train falling. After the train is lifted, technicians inspect the lower part of the train to ensure there is no damage or rust on the engine. If there is no damage, the workers replace the bogie and reattach it to the train. Once each part has been repaired, it is time to reconnect the train using a diesel locomotive. The technicians will reattach the separated sections of the train and reconnect the electrical lines, pantograph, passenger seats, and other components. They will also ensure that the components in the driver's cab and fire alarms on the train are functioning correctly. After confirming everything aligns with the procedures, the Sapsan train can resume its operation as usual.